Today we'll be covering Chapter 6, Lipids. The discovery of lipids, aka fats, happened in the 1800s when a young French scientist, Chevreul, separated pigments with vegetable oils, waxes, and resins. He would wash the glassware with soap and water, and one day he left some soapy water overnight and had salt crystals in the glass. And he didn't know where the salt crystals came from, and it was actually the oil reacting with the water. And soap is made from fat, and so that's where the discovery of fat came from the soap being left over into the glassware. Dietary fat was not considered essential until the early 1900s compared to carbohydrates and protein. And we started studying this in 1912, and they started doing this by feeding rats diets that were exceedingly low in fats and modifying the diets to see what the long-term effects were and which fats were essential and non-essential. If we look at this chart, it's showing you food sources of fat. So vegetable oil and butter or margarine. These two right here, they are 100% of their energy coming from fat. If we look over here at low-fat yogurt and fat-free milk, barely any of the calories coming from these two are from fat because we have processed the fat out of them. When you hear the word lipid, you may think of butter, lard, olive oil, and margarine, but we usually refer to lipids simply as fats and oils, and you can remember that fats are solid at room temperature and oils are liquid at room temperature. The triglycerides contain carbon, hydrogen, and oxygen. They do not dissolve in water, and you can remember this by the experiment of mixing oil and water in a water bottle. If you do half and half, and as much as you try to shake it, it will never combine. So fats and triglycerides do not dissolve in water. The family of lipids includes triglycerides, phospholipids, and sterols. Triglycerides are the most common type of lipid in the food and in your body. If we look at the structure of triglycerides, it's 3 fatty acids attached to a glycerol backbone. The fatty acids can be the same or different, and a molecule of water is released when fatty acids bonds to the glycerol. Esterification is the process of attaching a fatty acid to a glycerol, and hydrolysis is the reaction that releases fatty acids from glycerol to form free fatty acids. So whenever we're absorbing this and breaking them apart, hydrolysis reactions are occurring to make those free fatty acids occur. Just like when we talked about carbohydrates and we talked about some chemistry terms, we learned that di means 2, mono means 1. So a diglyceride is a triglyceride that has lost a fatty acid. So there's only 2 fatty acids on this. A monoglyceride is a triglyceride that has lost 2 fatty acids. So it's only having 1 fatty acid attached to that glycerol backbone. And reesterification is the process of reattaching a fatty acid to glycerol. So we're adding these fatty acids that have been lost back to that glycerol backbone. The basic structure of a fatty acid is long chains of carbon atoms linked together, surrounded by hydrogen atoms. Free fatty acids have a carboxyl group on one end and a methyl group on the other. And the carbon chains can vary, so the number of carbons are going to vary, the extent of saturation with hydrogen, and the shape, whether it's straight or bent. If we look at the carbon chain length, you have long chain fatty acids, medium chain fatty acids, and short chain fatty acids. So these two are going to enter the bloodstream whenever they are absorbed. And your long chain fatty acids go through your lymphatic system, so they're being absorbed in the lymph. And so if we think about whenever we covered digestion and absorption, these are all your absorptive cells at the top. Yes, I know my drawing's terrible. And we have all these capillaries in here. And then at the bottom, and the same thing goes in your book, we have this tube, and it's colored green in your book as well. This is your lymph. This is your lymphatic system. So this is where your long chain fatty acids are going. And then up here, And the capillaries is where these two are going. This is where they are absorbed and brought into your bloodstream. But the difference varies in the amount of carbons that are on here. So your long-chain fatty acids have 12 or more carbons. And you find these in beef, pork, lamb, and also in most plant oils. Your medium-chain fatty acids have 6 to 10 carbons, and it's usually coconut and palm oil. And your short-chain fatty acids have fewer than 6 carbons, and 3% of this is found in butter, or the fat in butter. The number of double bonds is going to determine the amount of saturation of that lipid. So a fatty acid can be saturated when all the bonds between carbons are single, so it's completely filled with hydrogen, there is no double bonds. Monounsaturated means one double bond is found in the chain, so it's missing 2 hydrogens. Polyunsaturated is at least 2 double bonds in the chain. There's missing hydrogens at double bonds. So once again, basic chemistry here. Mono means 1, so it's 1 double bond. And your poly has at least 2. At least 2 plus of the double bonds. So back to chemistry. You can recall that carbon can form 4 bonds. Oxygen 2 and hydrogen 1. So if we look at the saturated fatty acid, here's your carboxyl group on this end. Right here, here's your carboxyl group. And here's your methyl group over here. This is your fatty acid, and you can look at all the hydrogens. There's no double bonds. It is all single bonds to hydrogen. This is a completely saturated fatty acid. But if we look at this monounsaturated fatty acid, remember, mono means 1, so there's going to be 1 double bond in this fatty acid. So we can't look over here at this carboxyl group. This double bond to this oxygen, this does not count. You see the 2 carbons with this double bond right here, so we're missing 2 hydrogens. So this is a monounsaturated fatty acid because of this double bond right here. And whenever you're thinking of this, you can think of 2 different types of oils, which are primarily monounsaturated: olive oil and canola oil. So if we look at this polyunsaturated fatty acid, you'll see 2 double bonds, which is what's making it polyunsaturated fat. So it's missing 4 hydrogens, not carbons. So if we look at the shape of lipids, saturated and trans fatty acids have straight chains. Trans fats have hydrogens found on opposite sides of the carbon chain. These are the 2 types of fats that you do not want to consume. We want a lower amount of these. Lower. Unsaturated cis fatty acids have a bent chain. The hydrogens are found on the same side of the carbon chain, and you find this from oils from nuts and seeds. So if we look at this picture here, we can look at the cis formation and the trans formation. The hydrogens are on opposite sides, which is what's making it a trans form. And if we're looking at cis forms, you'll notice that both hydrogens are on the same side. Trans fatty acids are created during hydrogenation. The process of hydrogenation is adding hydrogen to carbon chains of unsaturated fats. And this is used in making squeezed margarine. We also find this in baked goods that are on the shelves for a long period of time because it is more shelf stable. So the chain becomes more saturated, solid, and straight. But once again, they use this because it's cheaper, and it also allows products to remain good for a longer period of time without becoming rancid. Just like when we talked about carbohydrates as well, the term essential means that your body cannot form it. So you have to consume this in your diet. So it cannot be made in the body. And the two essential fatty acids are alpha-linoleic acid, which is omega-3 fatty acids, and linoleic acid, omega-6 fatty acids. Most foods provide some triglycerides. Animal fat and vegetable fat are primarily triglycerides. Fat-free milk and yogurt, breakfast cereal, and yeast breads contain little to no fat, and fruits and vegetables are also low in fat. If we look at food sources of triglycerides like olive oil, it contains saturated, monounsaturated, and polyunsaturated fatty acids. But because it's mainly monounsaturated fat, it's referred to as a monounsaturated fat. So this is true of all types of food sources of triglycerides. They're going to contain a little bit of saturated, monounsaturated, and polyunsaturated, but the one that we're going to label it is determined on which one it has the most of. So if we look at this chart where it shows you saturated fats, monounsaturated fats, polyunsaturated fats, and trans fatty acids, you can look over here at saturated fats and see that coconut oil is mostly saturated fat compared to monounsaturated fats and polyunsaturated fats. So coconut oil goes in the saturated fatty acid column, just like butter, palm oil, and lard or beef fat. Next, we can look at monounsaturated fats. So olive oil, canola oil, and peanut oil all contain a little bit of saturated fat, but the majority of it is coming from monounsaturated fat compared to polyunsaturated fat. Same thing goes for polyunsaturated fats. If you look at the column over here, you can look and see it's almost 80% polyunsaturated fat with some mono and saturated fats. So some hidden fats are not visible in foods, but they're found in whole milk, cheese, pastries, cookies, cake, hot dogs, crackers, french fries, and ice cream. So if you look at these two pictures over here, french fries, the hidden fat is the oil that it's being fried in. So all the bubbles is the water leaving the potatoes and fat going in. If we look up here, this is butter and sugar being creamed together to make pastries, cookies, and cake. So the main ingredient is fat and also sugar, but the fat is hidden because you do not actually see it. And understanding how to read a nutrition facts label can actually help you understand how much fat is in the food. Triglycerides are essential for optimal health. It's a concentrated source of energy. They insulate and cushion organs, help transport nutrients. But high intakes, especially of saturated and trans fats, and imbalances of essential fatty acids can cause health issues. Triglycerides provide 9 calories per gram. So if we compare that to carbohydrates and protein, which is 4 calories a gram, and alcohol, which is 7 calories a gram, fat is the highest caloric energy yielding nutrient. It is the main fuel source for all cells except the nervous system and red blood cells. We use this when at rest or during light activity, so 30 to 70% of the energy supplied is by triglycerides. If we're looking at energy, the excess calories from carbohydrates, fat, protein, and alcohol can all be converted to triglycerides. And triglycerides are calorie dense, they deliver more energy, they're expandable to 2 to 3 times their normal size, and once you have them, which is a fat cell or an adipose cell, they are there permanently. There is no way for your body to naturally get rid of them. All that happens is if you have your starting weight and you're starting to gain weight, you see how they expand and they multiply. And when you lose weight, you still have these 4 cells, but they just shrink. So if you regain weight, then all they do is fill back up. And if you consume more than what your body needs, they just continue to multiply and fill up. Subcutaneous fat is found just below the skin. This is helping keep the body at a constant temperature. So if you look at this diagram on the slide, you'll see your subcutaneous fat right here. It's on top of your abdominal muscles. The visceral fat is beneath your abdominal muscles, and this is cushioning your organs and protecting your organs from injury. Essential fatty acids are important structural components of cells, and they help keep cell membranes fluid and flexible. DHA, which is formed from omega-3 fatty acids, are needed during fetal life and infancy for normal development and function of the retina. It's also needed throughout life for regulation of nerve transmission and communication. Phospholipids have a structure that is similar to triglycerides, except for one fatty acid is replaced with a phosphate compound. This allows phospholipids to function in a watery solution. So the phosphate head is hydrophilic and the fatty acid tail is hydrophobic. So when placed in water, the phosphate head will face water and the fatty acid tail will extend away from water. So if you look at this picture right here, you can see your hydrophilic phosphate heads up here because this is watery solution at the top. And your fatty acids are coming together down here. And this is going to form your cell membranes. So the cell membrane component of phospholipids are a double layer outer covering of the cell. It corrals cell contents, regulates movement of substances in and out of the cell, so you can see that in this diagram. It is also an emulsifier. It forms a shell around fat droplets and suspends them in a watery solution, essential for fat digestion and transportation, and bile and lecithin. Phospholipids in food are used as an emulsifier, so lecithin in egg yolks suspends fat in muffin batter. Phospholipids in egg yolks and mustard emulsify oil and vinegar to make mayonnaise. So if we look at this quick little video, you'll see some egg yolks, vinegar, and mustard, and it's actually going to make mayonnaise. But it's crucial that they have the phospholipids in the egg yolk to suspend everything and emulsify it together. Sterols includes cholesterol, which is used to make sex hormones, the active form of vitamin D, adrenal hormones, bile, cell membranes, and the shell covering of chylomicrons. But you can always remember that cholesterol is part of the sterol group because the name is in cholesterol. Cholesterol is found in foods of animal origin, so meat, fish, poultry, eggs, and dairy products, and it can also be synthesized in the body. There's no RDA for fat, but there is an adequate intake for infants. The Institute of Medicine's acceptable macronutrient distribution range is 20 to 35%, and it's also recommending that saturated fat, trans fat, and cholesterol be kept as low as possible. If fat intake exceeds 30% of your daily calories, monounsaturated fats should supply the extra calories, and cholesterol should be limited to 300 milligrams per day. However, the American Heart Association recommends lower amounts for those at risk of heart disease. So if you have a family history of heart disease, this is what your guidelines would be. Fat, no more than 20% of total calories. Saturated fat, no more than 7% of total calories. Cholesterol, no more than 200 milligrams per day. So you can see that they're recommending a little bit less in each category. If we look at the Mediterranean diet, up to 40% of the calories can be from fat, if most are from monounsaturated fats. So olive oil is the main fat used in the Mediterranean diet. You see an abundant intake of fresh fruit and vegetables, whole grains, beans, nuts, and seeds. It includes minimally processed and seasonally fresh local foods, low to moderate fish intake weekly, small amount of cheese and yogurt daily. They limit eggs and red meat, exercise also included on their pyramid, and they also have a moderate intake of wine. In America, we are consuming too little omega-3 fatty acids. While our omega-6 fatty acids intake is typically good, you should eat at least 2 portions of cold water fish weekly to meet omega-3 needs, and you can find this from walnuts, flaxseed, chia seeds, canola oil, soybeans, and flaxseed oils. If we look at fat digestion and absorption, digestion begins in the mouth with lingual lipase, and this is really active during infancy, but it plays a minor role in adults. It continues in the stomach, which is aided by gastric lipase, which once again, remember, if you see ASE, that means that it's an enzyme. So lipase is going to break apart lipids. It occurs mostly in the small intestine. Fat in the small intestine triggers the release of CCK, which causes the release of bile from the gallbladder, and lipase and colipase from the pancreas. So bile is going to emulsify fat and break it down into micelles, and it's increasing the surface area of lipids and allows pancreatic lipase to break down triglycerides to free fatty acids and also to monoglycerides. If we look at transporting lipids in the blood, lipids are transported in the blood as lipoproteins by chylomicrons, very low density lipoproteins, intermediate density lipoproteins, low density lipoproteins, and high density lipoproteins. And lipoproteins are composed of a core of lipids and covered with a shell of proteins, phospholipids, and cholesterol. So chylomicrons contain dietary triglycerides reformed in the absorptive cells, cholesterol, and phospholipids. The shell consists of phospholipids, cholesterol, and protein. These chylomicrons enter the lymphatic system via lacteals, and they travel throughout the lymphatic system to bloodstream, and they enter at the left subclavian vein. The nutrients are then transported to body tissues. So if we're going back to the small intestine, they're entering into the lymph system, the lymphatic system, and then they're going to travel to your left subclavian vein, at which point they're then entering your bloodstream. Very low density lipoproteins is when the liver can make fat and cholesterol from carbohydrates, protein, and free fatty acids. The liver coats the cholesterol and triglycerides with a shell of protein and lipids, called very low density lipoproteins, or VLDLs, and they enter the bloodstream. Lipoprotein lipase hydrolyzes triglycerides in the VLDLs, and this allows free fatty acids to enter cells. So it's pretty much breaking apart that outer shell, releasing the free fatty acids from the inside so the cells in your body can absorb it. At this point, you're creating an intermediate density lipoprotein, or an IDL, as the triglycerides leave. The IDLs lose more triglycerides by an enzyme called the hepatic triglyceride lipase, or HTGL. This creates a low-density lipoprotein, or an LDL, which are composed mainly of cholesterol. So we've talked about these before, but LDLs, or your bad cholesterol, these are your bad ones. Diets rich in saturated fats, trans fats, and cholesterol encourage plaque development from LDL. So this is encouraging the development of cardiovascular disease. So if we look at this picture, you can look at a normal artery, an early injury, so the beginning cholesterol plaque. So those LDLs are delivering cholesterol throughout the body, and you're starting to see this plaque buildup. Well, over time, you're going to have an advanced cholesterol plaque buildup, and it's going to get bigger and bigger and bigger until you have a complete blockage, at which point you're going to have a blood clot, which can lead to a heart attack or a stroke. Your HDL, or your healthy cholesterol, remember HDL, H and H, healthy. So your healthy cholesterol is called high-density lipoprotein. It has the highest proportion of protein produced by the liver and the intestine, and it roams the bloodstream picking up cholesterol from dying cells or other sources. So your healthy cholesterol is actually picking up the cholesterol deposits in your cells in your body, and it's donating the cholesterol to other lipoproteins for transport back to the liver, and then it's being excreted from your body. So it's removing them and completely eliminating it from your body. This helps to block the oxidation of your LDL bad cholesterol, and it slows the development of cardiovascular disease. Some health concerns to fat intake is high polyunsaturated fat intake can increase the amount of cholesterol deposited in arteries, impair the immune system. Excessive omega-3 fatty acid intake may impair immune system, allow for uncontrolled bleeding, and cause hemorrhagic stroke. Diets high in trans fat raise blood cholesterol levels, which also increases your risk of cardiovascular disease, lowers your healthy cholesterol levels, increases inflammation. So when eating out, you can avoid fried foods, pastries, flaky bread products, and cookies because the main ingredient is fat and saturated fat at that. And you can substitute at home with vegetable oils, soft or tub or squeeze margarine, and applesauce or fruit purees. If we look at cardiovascular disease, it is the major killer in North America, and high-fat diets, especially those saturated in trans fats, significantly increase the risk for cardiovascular disease, and symptoms develop over several years. So if you're consuming a diet high in saturated and trans fats, you will not see the effects today or tomorrow. It might be 20, 30, 40 years from now before you see the effects of it. Some modifiable risk factors for cardiovascular disease is having a total blood cholesterol level over 200 with LDL levels above 160, blood triglyceride levels over 150, hypertension, smoking, physical inactivity, obesity, diabetes, liver and kidney disease, and low thyroid levels. Some non-modifiable risk factors for cardiovascular disease is being over the age of 65 years old. If we're looking at gender, males have a greater chance of developing it than women prior to menopause. If you have a close relative who died prematurely of cardiovascular disease, it increases your risk. And African, Hispanic, Latino, Native American, Native Hawaiian, and some Asian groups have a higher risk. If we're looking at the symptoms of a stroke, it can include numbness or weakness of face, arm, or leg, confusion and or trouble speaking or understanding, trouble seeing, trouble walking, dizziness, and or loss of balance or coordination, or a severe headache. Heart attack symptoms include intense, prolonged chest pain or pressure, sometimes radiating to other parts of the upper body, shortness of breath, sweating, weakness, nausea and vomiting, dizziness, jaw, neck, shoulder pain, and irregular heartbeat.